Hello, good evening students. Today we are going to understand that is work done in isothermal reversible process, right student? So dear students, some information we can conclude here. Firstly, this is isothermal, okay? Isothermal means temperature is constant, temperature is constant. So throughout the system, the temperature is fixed, means delta T equal to 0. That is, it is not going to change. Reversible process, I told you student, reversible process. So reversible process means what? That is, work is very slow student, process is very slow. Process is very slow. It is a very slow. Okay. Firstly, process is very slow, and that can be reversed anytime. Okay. Which can be what student? Which can be reverse at any time. Okay, which can be reversed at any time. Okay, this is what is known as what student? Reversible process. So that is, we have to keep in mind student, that is isothermal means that is temperature is constant. Reversible means the work is very slow student. So it always look like that it is in the equilibrium only. Okay, it is so slow that it is look like that is the process is always in the equilibrium. Okay, and anytime if you are removing that force, okay, you are applying that is against the force, that process can be reversed. Okay, that you have to keep in mind. Okay, now student, that is a reversible process we have to understand, because this is the only important, okay, important topic of the work, So here you see students, how can you be understand? Suppose we are having the one system is there student, right? It is having, in this system we have filled out the gas. Okay, this is the gas are there students. Dear students, you can see this is what is there student. These are the gas are there, right? This is the gas. A gas is filled. Now what we are going to do here? That is, the pressure is there. Okay, so this pressure is what student? This pressure is small particles are kept. Small particle, very small particles are kept. Okay, this you can see, that is how small particles are kept. Too much small particles are kept. Okay, so see, the inside pressure is there. So that pressure we are talking about, that is P system. Okay, this pressure is talking P system. It is the against that, it is going this direction. Okay, this is going this direction. Okay, now this side, whatever the force if you are putting here, this or whatever there, the small weight are there student. Okay, this weight is what? This weight is what? This is what is external pressure. These are what student? That is external pressure. External pressure, right? External pressure. Okay, so now student, you remove this very small particle. This is very small particle. Okay, very small particle. Okay, what I am going to do is student, removing. Okay, remove. So firstly the system was in the equilibrium. Now you remove that one. So if you are removing, dear students, what will happen if you are removing? So that is P system, whatever there student, P system, okay, will be greater than what student? Will be greater than P external, because if you are removing a small part of this weight. Now if you want to calculate P system, okay, if you want to check P system, so what is coming student? P external, we have to add some amount of pressure. How much student? Suppose I am adding the dP. Okay, this pressure I am adding. So this is what is implying that student, this is implying that this is the reversible system. Means that is, if you are removing very small particle, so that external pressure will be little decreased and system pressure will be high. So gas will expand very slow. Okay, again if you are putting that one, so gas will get compressed. It means that is the process is getting reversible. If you are applying this force, it will compress. If you are removing a small one, that is expand. Okay, so how the work is taking place student? This work will be taking place very slow. Suppose if it is the compression, so the gas will be very it is getting slow. This is the volume axis, this is the pressure axis. Okay. Now if someone is asking to calculate the work, someone is asking to calculate the work. So here you see the pressure is continuously changing. Okay, pressure is here, you can see that is pressure is continuously changing. So if pressure is continuously changing, so that is W is equal to what we apply, P external delta V. So this we cannot use na, P external delta V, because pressure is continuously changing. So what we can do? So what we can do? We have to select a small area. We have to select this small area. Okay, this is small. Okay. So if you are selecting this small, then what we have to do? Then we have to integrate. Okay. Then after selecting this, we have to integrate. So if you are integrating, so as a whole you can calculate the work. Okay, as a whole. So dear students, I am selecting very small area. Let us see. It's a very tricky, students, very tricky and very interesting also. Okay, at the same time it is tricky and at the same time it is very interesting. So dear students, I am taking very small area. Suppose I am taking this portion, this one. Okay, and then I am taking this one, and then I know what I am going to do. Then I am integrating. So that is, if there is the displacement here, PV displacement is how much? That is suppose the change in pressure is dP. Okay, a change in the volume is what, student? dV. Okay, and that is work done is dW. So dear students, how can you calculate here? If you see the work done, if you are calculating, student, so simply what we are going to do, student, if you are integrating, so dW is equal to what is, student? Okay, so it will be, that is P external. Okay, and here we can say that is dV, P external, and delta V we can write, student, P external delta V. Okay, for the small volume. Okay, and this we are going to integrate because the pressure is very small change, student, because we remove the mass is very less. So I am putting that is pressure is almost the same, and we are going to change in the volume is little bit, dW. Okay, so dear student, what we are going to do? So we are going to integrate this equation, So if you are integrating here, so what will come, student? dW, and here you are integrating, so negative sign is there, P external, and we can write dV. Okay, so if this term is in the volume term, so we need there also volume term to integrate. So what we are doing, integration of dW is how much, student? The integration of dW is the W only. Okay, here what we can see, minus, here is the, we can write V1 to V2, and here is also V1 to V2. And dear student, you see, if you see from ideal gas, okay, here I am writing from ideal gas, what we can write, P, okay, PV is equal to nRT. Since system is equilibrium, so we can write that is P external. So P external is equal to nRT by what is V. So we are putting this value here. So this you can see, nRT by what is, student? V, and dV, nRT, nRT V upon dV. So dear student, again what we can do here, that is we know student, nRT, isothermal process, so temperature is constant, R is gas constant, number of mole is fixed. So here W is equal to what we can write, student? That is nRT is the outside, here is the V1 and this is the V2, and here is 1 upon volume, and D volume. Okay, now you see, students, you see that is what is the case is coming. Okay, mathematical term is there here, that is here I am defining. Okay, so here if it is there like a student, that is V1 V2, okay, and here is 1 upon V dV is there, so it will come, student, ln V, and here is, that is what is V1 V2, this is value. So here I am writing better, I am writing here this one system, what is coming, student? Here you can see W reversible is equal to what will come, student? Minus nRT, this is there, and here will come ln, okay, and here is V, and here we can write that is lower limit, upper limit. Okay, now dear students, what we can do here, okay, W is equal to minus nRT, ln is there, ln, here we can write student ln V2, okay, minus ln V1. This one there student. Now what we have to do, we have to change ln into log. Okay, we have to change ln into log. So how can you change ln into log student? By multiplying by the conversion factor. So minus 2.303 nRT log, what will come student? B2 minus log what? B1. We know student log A minus log B is equal to what student? Log A by B. So what we can write students, W reversible is equal to how much is coming? Minus 2.303, it is nRT log, it will come student V2 upon what? B1, B2 upon B1. This is our the first expression for the reversible process. Okay, from PV is equal to nRT, from PV is equal to P1, from the equation P1 B1 is equal to P2 V2. Okay, so here if you are taking P1 upon P2 is equal to what? B2 upon B1. So at the place of B2 upon B1 we can write P1 upon P2. So what is coming here? W is equal to student minus 2.303 nRT and log nRT log, what will come student? P1 upon what is P2. nRT W is equal to minus 2.303 nRT log P1 upon P2. This is what is the our expression for the work done in the isothermal reversible process. Dear students, let us try to solve some of the problem based on it. Okay, so wait, I am writing the problem and then we will try to find out that is what is the solution, how can we do the problem based on the reversible process. Okay, so dear students, the question here is there, 10 gram of argon is compressed. Here they are saying question student, 10 gram of argon, 10 gram of argon is compressed. You are compressing 10 gram argon is compressed. How much student? Isothermally and reversibly, isothermally and reversibly, isothermally and reversibly. Okay, so that is again they are saying student, at temperature of 27 degrees Celsius, at temperature of 27 degree Celsius, from 10 liter to 5 liter, from 10 liter to 5 liter. Again what the term is there, calculate Q, W and delta U. Calculate, what is the calculate? Heat. Okay, calculate, they are saying Q. Okay, then see here then W and that is and delta U. These three things are there. If R is equal to how much saying student? R is equal to 2 calories. So this is the question and we have to do the solution. So firstly we have to understand this is what kind of process is there, isothermal reversible process. So if you are calculating W, so W is equal to what student? Minus 2.303 nRT log V2 upon what student? B1. Here you can see here the volume is there. How much volume is there student? 10 liter. Initially they are saying that is 10 liter, and if you are compressing this applying by pressure, so they are saying that is volume is converting into 5 liter. So this is the V1 and this is the V2. So here, and how many 10 gram is there student? 10 gram. And argon atomic mass how much is there student? 40. So n argon how to calculate? That is given mass upon molar mass. Okay, given mass is 10, molar mass is 40. So how much is coming? 10 10 cancel out, 1 by 4. So 4 2 ja 10, 4 5 ja 20. So 0.25 mole is coming, right student? 0.25 mole of argon is coming. So here you put out the mole value. So W is equal to how much is there student? Minus 2.303, n value how much is there? 0.25 multiply by R 2 calories. Here they have given T how much is there is 27 degrees Celsius. So T is equal to, they have given 27 degrees Celsius. You can convert into Kelvin. 27 into how much? 273 Kelvin. So how much? 300 Kelvin is coming. So here you can multiply by 300 into what will coming, student? Log V2. V2 how much is there, student? That is 10 liter, and here is how much coming, student? V2 is 5 liter. So it is coming 5 by how much, student? 5 by 10. Okay, solve it out, student. Minus 2.303 into 0.25 into 2 into 300 into log how much coming? 5 to the 10, 1 by 2. Okay, so here you can solve it out, student. How can you be able to do? Minus 2.303 into 0.25 into 2 into 2 means 2 3 are 600. Okay, simply, and with this, student, 2 decimal and 2 0 is cancel out. So here is 25. This is coming how much? 25 multiply by 3 2 are 6 into what is log 1 minus log 2. Log 1 value is 0. Here is, so minus 2.303 into 25 is there, student. 6 5 ja 30 and 6 2 ja 12. 12 3 how much, student? 15 into log 1 value 0 minus how much? Log 2 value 0.3010. Okay, so you can solve it out, student. Minus 2.303 into 150 into minus 0.3010. If you are solving this all, student, how much value you are going to get? You are going to get plus 103.98 calorie. Plus, because minus into minus plus. Okay, this is the plus. How much? 103.98. This is coming in the term of calorie. So W reversible you got, student. W reversible you got how much? 103.98 calories. Right? Now what we are going to do, students, we are going to calculate the other things which is required for this. They ask calculate Q. W we got, and we have to calculate U also. So since, student, this is the isothermal process, okay, that you have to keep in mind. If it is isothermal process, so here internal energy will be 0. Why? Because temperature depend on all the energy. Internal energy is directly proportional to temperature. So since we can write that is since the process is isothermal, since the process is what, student? Process is isothermal. Okay, since the process is isothermal, that is delta T equal to 0. So delta U is equal to what? 0. So that is delta U also we got. Now that is Q, they are asking Q. So from first law of thermodynamics, from first law of what? Law of thermodynamics. So you are going first law of thermodynamics. Okay, so how can you be able to solve that is from first law of thermodynamics, students? Let us try to have a look over it, student. From first law of thermodynamics, what? That is delta U is equal to Q plus W. So delta U was 0 here, we already said. Okay, so that is Q plus W, or Q is equal to how much, student? Q is equal to minus W. So Q is equal to minus W value here is there. So minus 103.98 calories. So this was our required answer for this isothermal process. Thank you so much for watching, friends. We'll try to do some more problem based on it, okay, in the next video. Thank you so much for watching, friend. If you find this video helpful, please do like and subscribe the channel, student. Thank you, student, for supporting.